Okay, before I go on to the root test, I want to cover one last point on ratio test, and that is when you see a factorial, something like n factorial in a problem, a rational function, it's a pretty good guess that that's going to be solved by the ratio test. You know that when you're looking for convergence and divergence, you kind of have a toolbox. Well, one giveaway for what tool to use is if you see a function, and this is example 1 part B, and we get that the function is equal to 2n factorial over n factorial times n factorial. And you remember, just a quick review, like 5 factorial is equal to the numbers 1 through 5 multiplied together, so it's 1 times 2 times 3 times 4 times 5. So that's what a factorial means. Okay, and algebraically, factorials are kind of crummy to deal with. So how are we going to, solve this problem? Does this series, converge if we're looking at something like that? Well, let's use the ratio test. And, we're going to make the ratio of an plus 1 over an, right? So we've got to start out with, write out the an plus 1. Well, all we do is it's going to be 2 times n. Actually, let's just do it this way. 2n plus 1 factorial over n plus 1 factorial n plus 1 factorial. And you don't FOIL these. No, it doesn't work that way. These are factorial. You have to kind of treat them special. This thing here we can rewrite as simply 2n plus 2, that whole thing factorial, over n plus 1 factorial n plus 1 factorial, which kind of looks like a mess. But now we make our ratio, and remember the first thing we're going to do is we're going to simply invert this a sub n term, this thing right here, and multiply it by this. So let's just do that. N factorial, see I'm taking the reciprocal of it, n factorial, and 2n factorial. Now the neat thing about this, in fact the whole reason this is interesting and good to deal with factorials, is we get to cancel the bejesus out of things. See, this is 1 to n multiplied together times 1 to n multiplied together, which is really boggling, alright? But we have almost the same thing down here. This is 1 to n multiplied together, and this is 1 to n plus 1 multiplied together. This whole thing cancels with every term in this except for the very last term, the n plus 1 term. So if I cancel this whole thing, it just eradicates that factorial sign. This eradicates this factorial sign. Now we just have n plus 1 times n plus 1 here. This 2n cancels not quite as completely here. This thing is going to have 2 extra terms, right? Because this is 2n plus 2. So what is left over after I cancel this whole thing up here? We have 2 terms. It's 2n plus 1. That's one of the terms that was above 2n. And 2n plus 2. Alright. Yeah. Well, that was pretty good. And that's why ratio tests are so great for factorials. So let's rewrite it down here. And this is gone through in your book, so you can look at that. I'm going to kind of, see this 2 here? I'm going to cheat that 2 out of there. Just factor it right out. Now I can factor out and do all kinds I want because the factorial signs are gone. And this just becomes n plus 1. And in the denominator we get n plus 1 times n plus 1. You can see now why I factored that 2 out, is so I could do this cancellation like this. I multiply this 2 through here, and I get 4n plus 2 over n plus 1. Okay? And then what I can do here is, we think about our limit as n goes to infinity, and obviously this is going to go to 4, and that is equal to our rho, and rho is greater than 1, therefore we'd have to say this series diverges. And the point of this example is really to emphasize, if you see that little factorial sign in a rational function, very likely the root test would be a good thing to at least think about.